Welcome to AI Smart Bytes. In today's video, we'll be exploring the fascinating and often mind-bending concept of quantum computing, breaking it down into understandable parts and explaining why it's poised to revolutionize industries and change the future of technology. First, let's start with the basics. What is quantum computing? At its core, quantum computing is a type of computation that leverages the principles of quantum mechanics, the theory that explains the behavior of matter and energy at very small scales, such as atoms and subatomic particles. Now, you might be wondering, how is this different from traditional computing? In classical computing, data is processed in binary form, meaning it exists as either a 0 or a 1. These bits are the building blocks of traditional computers. However, quantum computing introduces a new way of thinking with quantum bits, or qubits. Qubits are special because they can exist in multiple states at once, thanks to two quantum principles, superposition and entanglement. Superposition allows a qubit to be both 0 and 1 simultaneously, unlike classical bits that are either one or the other. This means a quantum computer can process a vast amount of information in parallel. For example, a quantum computer can evaluate thousands of possible solutions to a problem at the same time, significantly speeding up complex calculations. Next, we have entanglement. When qubits become entangled, the state of one qubit can instantly affect the state of another, even if they are far apart. This property has been described as spooky action at a distance, and it allows quantum computers to solve problems much more efficiently than classical computers. For example, in certain quantum algorithms, entangled qubits can share information so quickly that problems that would take classical computers years to solve might be completed in minutes or hours. So, why does this matter? Because quantum computers have the potential to solve problems that are practically impossible for classical computers to handle. They could revolutionize fields like cryptography, artificial intelligence, drug discovery, and more. Let's dive deeper into one of the most exciting applications, cryptography. Today, encryption protects everything from online banking to private communications. Classical computers rely on algorithms that are tough to crack, such as RSA encryption, which is widely used to secure communications and financial transactions. However, quantum computers can break many of these encryption methods much faster. They can use an algorithm called Shor's algorithm to factor large numbers exponentially faster than classical computers, rendering RSA encryption vulnerable. But don't worry. Quantum computing also opens up new doors for developing more secure encryption systems, ones that are based on the principles of quantum mechanics themselves. These quantum secure systems, like quantum key distribution, QKD, use entanglement and the uncertainty principle to create encryption that is virtually unbreakable. With QKD, even if someone intercepts the data, they cannot read it without disturbing the quantum state, alerting both parties to the breach. Now, let's look at another exciting application, drug discovery and molecular simulations. Quantum computers have the power to simulate complex molecules at a level of detail that classical computers can't match. For example, drug development often involves modeling the interactions between molecules to understand how new compounds might react in the human body. Classical computers struggle with this, as simulating molecules requires huge amounts of computing power. Imagine designing a new medication tailored to treat diseases like cancer or Alzheimer's. Currently, drug researchers must test thousands of compounds in the lab, which is time-consuming and expensive. With quantum computing, scientists could simulate the interactions between drug molecules and their targets, predicting which compounds will work best against diseases like cancer. This could dramatically speed up the discovery process, allowing for personalized medicines tailored to individual patients' needs. One company, for instance, is working on using quantum computing to simulate the interactions of molecules in the human body, which could lead to groundbreaking cancer treatments. Another fascinating use of quantum computing is in optimization problems. From logistics and supply chains to financial markets, optimization is a challenge that classical computers struggle with when it comes to large, complex systems. Take the problem of scheduling flights for an airline. Classical computers can handle basic tasks, but when there are thousands of flights, crew members, and aircraft to coordinate, the problem becomes exponentially more difficult. Quantum computers can process all these variables simultaneously, finding optimal solutions much faster. Quantum computers can also be used to optimize traffic flow. Cities around the world are using algorithms to manage traffic, but with the introduction of quantum computing, we could achieve much more efficient traffic management. Imagine having the ability to adjust traffic lights in real time, taking into account factors like weather, road closures, accidents, and the flow of traffic to minimize congestion. Quantum computers can solve these types of dynamic optimization problems much more efficiently than classical systems. But what are the challenges of quantum computing? Well, for one, building a practical quantum computer is incredibly difficult. Quantum systems are extremely delicate and prone to errors. They require very specific conditions, such as ultra-low temperatures, to function properly. Some quantum computers are currently cooled to temperatures colder than outer space, which is necessary to reduce the interference of thermal noise that could disrupt the quantum states. Another major challenge is scaling quantum computers. Currently, quantum computers are still in the experimental phase, with only a few qubits being used in research and development. To reach their full potential, we'll need quantum computers with thousands, if not millions, of qubits. As researchers work on improving the stability and error rates of qubits, the dream of a practical, large-scale quantum computer is slowly becoming more attainable. Despite these challenges, significant progress is being made. Tech giants like IBM, Google, and Microsoft are pouring resources into quantum computing research, and countries around the world are establishing national quantum initiatives. In 2019, Google claimed to have achieved quantum supremacy, demonstrating that their quantum computer could solve a specific problem faster than the most powerful classical computers. It's clear that quantum computing is no longer just a concept for the future, it's actively shaping our present. Let's talk about how quantum computing can impact artificial intelligence, AI. AI, as powerful as it is today, could become even more advanced with the help of quantum computing. Quantum computers can process large datasets and perform complex calculations much faster than classical computers. For example, AI systems like deep learning and neural networks rely on vast amounts of data to learn from, and quantum computing could speed up the training of these systems, leading to more advanced AI models. This could lead to breakthroughs in areas like machine learning, pattern recognition, and even self-driving cars. Quantum-enhanced AI could revolutionize industries such as healthcare, where AI could make more accurate predictions and diagnoses by processing larger datasets. In self-driving cars, quantum AI could analyze traffic patterns, road conditions, and real-time data more efficiently, improving the safety and efficiency of autonomous vehicles. One of the key advantages of quantum computing is its ability to solve problems in parallel. This means that a quantum computer can evaluate many possible solutions to a problem at the same time, drastically speeding up the time it takes to find an answer. This is a major breakthrough when it comes to tasks like optimization and complex simulations. As we continue to advance in quantum research, the potential applications are truly limitless. But it's important to note that quantum computing won't replace classical computers. Instead, it will complement them, solving problems that classical systems can't handle. Classical computers will continue to be used for everyday tasks, while quantum computers will tackle the more complex challenges. The future of quantum computing is incredibly exciting. With advancements in hardware and software, we could soon see the development of quantum systems that are powerful, stable, and scalable. These systems will open up new frontiers in science, technology, and business. In conclusion, quantum computing is one of the most transformative technologies on the horizon. Its ability to handle complex calculations and solve problems that were once thought to be unsolvable is what makes it so powerful. While there are still many challenges to overcome, the potential is undeniable. Thank you for joining us today on AI Smart Bytes in this deep dive into the world of quantum computing. We hope you've gained a deeper understanding of this groundbreaking technology and its potential to change the world. If you enjoyed this video, don't forget to like, share, and subscribe. By subscribing, you'll stay updated on all our future videos exploring the latest innovations and trends in technology.